Roman numeral part 1. So question number 9. We have to show that an equation can be rewritten in another form. So that'll just be a combination of trigonometric substitutions and algebra moves until the first equation becomes the second. So that's my strategy for Roman numeral part 1. Roman numeral part 2 is to notice, the strategy is to notice that this equation uses something from part 1. So I'm going to use part 1 and then hope for the best. So here I am, Roman numeral part 1. So we are given this. Now, it is a cold hard fact, in fact they've told you to use this fact, that cos squared theta plus sin squared theta equals 1. That enables you to make 6 substitutions. If you see that, you can replace it with that. If you see that, you can replace it with that. If you see this, you can replace it with that. If you see this, you can replace it with that. If you see this, you can replace it with that. I don't know why you'd want to. And if you see this, you can replace it with that. Which of those is most useful here? Let's keep the goal in mind. We're trying to produce something that only has sines in it, no coses. So let's get rid of that. Let's replace this with that. This is an algebra move just now. That was a trig move. This became this. Now I'm just expanding the bracket. I'm going to take away 2 from both sides. That's an algebra move. And now times everything by -1. That's another algebra move. So that's Roman numeral part 1 done. So we now have to solve this equation, but we've discovered it's the same as that equation. The trigonometry applies to theta, so does the permission statements, that's good. Classic trap would be if the trigonometry had applied to 2 theta there. But that's not the case here. So how are we going to solve this? Now you can't solve trigonometric equations until they fit the template. So sine theta equals something, or tan something equals something, or cos something equals something. This is far from that, so let's make it look like one of those. My method is to factorize here. Now out of that, this is a very special situation that you first learn when you're solving quadratic equations. A product coming out to be 0 is super special. A product can only come to be 0 if each element of the product is 0, or it can only happen if at least one of them is 0. So that's a possibility, and that's a possibility. That is sweet, it fits the template, so that's good. This one will fit the template in a second. So, what's your basic angle for that? 30. I just know that off by heart, but you can do shift sign on the calculator if you want. This is your x-wing fighter. We did that and that, not, well done, that and that, not that and that. Because anything's positive there, that's A for any. Sine is positive there, which it clearly is, because it's half, not negative half. So, our task is to get to those using angles that we're permitted to use. So, can get to there with a 30, can get to there with a 150, just go to 180, then pull 30 back. What about this? Now sine theta you learn over SOHCAHTOA in year 9, but then you learn that it's, in ADMAS, that it's swinging around the circle. So swing round. How can you get a fat dot with a height of 0? It can be there or there. So in other words, theta equals 0 or 180. So the final answer is 0, theta equals 0 or 30 or 150 or 180. Just going to check the answer that is correct. Yep, it is.